Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू
हेलो स्टूडेंट्स आज टॉपिक रे आमे फ्रेस्नेल डिफ्रैक्शन एट ए स्ट्रेट एज ए विषय रे पढिबा सो फर्स्ट गोटे स्ट्रेट एज कहले आमे कोन बुझिबा इट इज ए sharp edge obstacle okay and it is placed in the path of the beam of light okay so sharp edge obstacle माने एटा को आमे गोटे रेजर ब्लेड बा गोटे रेजर एज ए हिसाब रे नै परिबा ओके जनरली ऑप्टिकल बेंच रे ए एक्सपेरिमेंट परफॉर्म करा जाय प्रैक्टिकल रे ओके सो यू कैन सी हियर in the figure here S is the source of light from which the light is coming and it is passing through this narrow slit okay so a source जो light टा आसुची suppose आमे याकू कहला XPY एटा आसुची गोटे cylindrical wave front okay because it is at a finite distance मन रखो Fresnel diffraction रे the source is at a finite distance from the obstacle and also screen okay so what is cylindrical wave front he gala ethi XPY right and at any instant this wave front is in the horizontal plane right now an opaque obstacle here this one is an opaque obstacle having a sharp edge okay ethi dekho ei jo pointed area ta achi eta this is a sharp edge at the point P here okay this point so it obstructs the portion of this wavefront from falling on the screen जोटा कि एठी पछरे हमें स्क्रीन टा रखिछु okay now as per the geometrical consideration geometrical point of view जदि देखिबा ताले there should be uniform distribution of light above this normal point O okay normal point माने SPO एटा होची normal direction O रो ऊपरे uniform distribution light रो हबा कथा आ O रो तळे completely darkness रहिबा कथा okay this is as per geometrical consideration but however experimental observation actually याठू टिके अलगा result देखेला okay so first ये कहूची below the point O रो तळे okay where there should be zero intensity माने completely darkness रहिबा कथा actually देखा गला जे there exists some light okay and the intensity falls very rapidly below the point O okay এটা হলো first point second point above the point O where there should have been uniform distribution of light actually देखा गला there exists a number of dark and bright bands okay and these bands go on becoming more and more closer as we move above the point O ରୁ ଯେତିକି ଆମେ ଦୂରକୁ ଯିବା ତାହେଲେ এই बैंड्स गुडा भितरे जो गैप टा रहउची सेटा कमी कमी जीवो राइट सो याकू एबे हमें एक्सप्लेनेशन टा देखिबा ओके सो फर्स्ट देखिबा बिलो द पॉइंट O ओके सो जो हमरो पॉइंट P अछि वेव फ्रंट रो मझी पॉइंट टा ताकू हमें कहिबा पोल बोली कि सही वेव फ्रंट रो ओके नाउ द इंटेंसिटी एट O is due to the exposed part okay बा exposed half जोटा रहउची which is px wave front को because अधा रे भाग कर दउची ए obstacle okay so the intensity at the point O is due to the exposed half that is the upper half px of the wave front ताले amplitude एबे ए जो point O रे केते हेबो एटा हम ऑलरेडी देखिछु suppose एटा हला AO or A0 which is equal to m1 minus m2 plus m3 minus m4 and so on जार वैल्यू हमें पाउथला m1 by 2 right now intensity obviously it will be proportional to the square of amplitude, so I0 by IO is equal to KAO square, okay, or K into M1 square by 4. Okay, now as we move from O to O1, okay, so again coming back to the figure, ଏଠି ଦେଖ point O ରୁ ଆମେ ତଳକୁ to a point O1 ପହଞ୍ଚିଲା, okay. Now here you can see the pole जोटा कि प्रथमे point P रे थिला, this will now shift to another point that is P1. Okay, so the pole of this wavefront moves from P to P1 in such a way that first half period element in this upper half will now be obstructed by this obstacle. Okay, ei part ta ebe obstruction re asila upper half ro. Okay, so this exposure now starts from the second half period element because first half period ta पूरा obstruct करिगला, ओके, ब्लॉक हेगला। ता माने एबे जदि आमे पॉइंट O1 रे एम्प्लीट्यूड बाहर करिबा, सपोज तार वैल्यू हैला A01, ताले यार वैल्यू एबे केते हबो देखो, A01 is equal to minus M2 because M1 एठी कटि जाइछि because first half period element block हे जाइछि, so A01 equal to minus M2 plus M3 minus M4 plus M5 and so on, or its value is minus m2 by 2. Okay, ताले intensity which is proportional to the square of amplitude, so यार value हैला I01 equal to k into A01 रो square or k into m2 square by 4. Okay, ताले आमे जानिछु जो amplitude for the first half period element will be greater than that of the second one. Okay, so m2 is less than m1 or m1 greater than m2, ताले I01 will be again less than I0. so आमे देखिला जे जते जते आमे तळकू जाउछु intensity कमी कमी जाउछि. Okay, so as we go further down, more and more half period element एबे block हे जिवो, they will be obstructed, so this explains the sharp decrease in the intensity below the point O. Okay, now second one, the intensity at the point O. Okay, आमे जेमति देखिला effect जो point O जोटा कि normal point, it is due to the upper half of the wavefront only. Okay, hence the displacement at this point O is half of the displacement which would have been there if the whole wavefront was effective. जदि whole wavefront थांता ताले displacement टा जेतकी ही थांता तारो अधा हे जाउची because अधा part wavefront रो केवल exposure रे आसुची, आ अधा को से जो straight edge टा ढांकी दोउची, right. ताले intensity एबे केते हेबो, it will be 1 by 4 times of the intensity at a point far removed from the point O where the whole of the wavefront is effective. Okay, जदि पूरा wavefront टा effective ही थांता ता पई जेतिकी intensity आस्तांता, एबे ए straight edge जोटा कि अधा wavefront को ढांकी दोउची, so intensity 1 by 4 times हे जाउची, right. अच्छा, थर्ड पॉइंट को एबे आसीबा, थर्ड पॉइंट हैला above the point O. Okay, so again याकू बुझा पाई let us go to the figure again. Okay, so देखो point O हमरो थिला normal point. Okay, normal point O रू हमें एबे ऊपर को जिबा. Okay, suppose we go or we move to a point R above this point O, right. ताले एबे ए जो पोल जोटा कि स्टार्टिंग रे पॉइंट P रे थिला, this will be shifted to another point that is P prime or P dash. Okay, thus the amplitude of light at this point R will be equal to light from one half that is P dash x. Okay, ei part जो light आसुची ता पई एबे effective हबो plus light from P dash. Okay, a part B, so this part plus this part. Okay, এই দুইটা part ପାଇଁ light ଆସିବ ଆଉ R रे एटा intensity create करिवो. Okay, because both these two parts are now exposed. Okay, so these are the exposed portion of the second half. Okay, now light from one half that is P dash x एटा. Okay, so एटा already हमें यारो value टा पाई थिला जो amplitude टा केते थिला m1 by 2. Now लाइट फ्रॉम पी डैश पी एटा बाहर करिवार अछि सो देखो ए जो पी डैश पी बा पी डैश अछि actually this is the exposed portion of the second half and it depends upon the number of half period elements which is contained between these portion that is pp dash okay suppose ame कहला जे it contain even number of half period elements then the contributions will be mutually cancelling each other जेतु even संख्या रे अछि thus it will give you nominal light okay and this will result in a minima okay ଆଉ ନାଇଁ ଯଦି p p dash ଭିତରେ ଆମେ କହିଲା ଯେ odd number of half period elements ଅଛି then we will get some sizable contribution okay so sizable contribution ହେବା ଦ୍ୱାରା ଏବେ ସବୁ mutual cancellation ହେଲା ପରେ ବି କିଛିଟା contribution ରହିଯିବ okay and this will result in production of a maxima at the corresponding point of observation which is the point r okay so r रे maxima ହେବ କିମ୍ବା minima ହେବ ସେଟା এই p p dash ଭିତରେ କେତେ ସଂଖ୍ୟକ even ନା odd କେତେ ସଂଖ୍ୟକ half period elements ଅଛି ତା ଉପରେ depend କରୁଛି okay now as we move gradually above the point o okay ତାହେଲେ ପୁଣି ଆହୁରି ଆକୁ ଯଦି ଆମେ ମୁଭ୍ କରିବା ତାହେଲେ ଏଇ ଯୋଉ ପି ପି ଡ୍ୟାସ୍ ପୋର୍ସନ୍ ଅଛି ଓକେ ୟାର ବି ଗ୍ୟାପ୍ଟା ବଢ଼ି ବଢ଼ି ଯିବ ଓକେ ଦ ସାଇଜ୍ ଅଫ୍ ଦିସ୍ ପୋର୍ସନ୍ ପି ପି ଡ୍ୟାସ୍ will also increases gradually therefore the number of half period elements which is contained in this region will undergo a variation okay thore odd habo thore even habo enti alternately vary karibo as a result we will get a number of dark and bright bands মানে number of minima and maxima okay above the point o right so ଏବେ ୟାକୁ ଆମେ ବୁଝିପାରିବା ଗୋଟେ କମ୍ପ୍ଲିଟ୍ ମ୍ୟାଥମେଟିକାଲ ଷ୍ଟଡି ଯଦି ଦେଖିବା ଏ ଡିଫ୍ରାକ୍ସନ୍ ବ୍ୟାଣ୍ଡସର ଓକେ ସପୋଜ ଦେଖ ଏଠି ଫିଗରରେ ଆମେ କହିଲା ଯେ ଓ ପି ଓକେ ଓ ପି ଇଜ ଇକ୍ୱାଲ ଟୁ ସ୍ମଲ୍ ଏ ଆଉ ଏସ୍ ପି ଇଜ ଇକ୍ୱାଲ ଟୁ ସ୍ମଲ୍ ବି ରାଇଟ୍ ଆଚ୍ଛା ଏଠି ଆମେ ଓ ଆର୍ କୁ ନେଇଗଲା ସ୍ମଲ୍ ଏକ୍ସ okay which is the distance between the point of observation that is r and the normal point that is o okay তাহলে ଏବେ path difference okay path difference between the rays of light which is starting from p and p dash okay এই जो दुईटा रे तमे देखବାକୁ ପାଉଛ এই ଦୁଇ रे ଭିତରେ path difference टाकू ଯଦି ଆମେ କହିଲା delta ତାହେଲେ this delta will be how much pr minus p dash r ଏତିକି ହିଁ ହେବ ଓକେ ୟାର ଭ୍ୟାଲୁ ଆଚ୍ଛା ତାପରେ ଏଠି ଲକ୍ଷ୍ୟ କର ଯୋଉ ଆମର triangle ଅଛି PRO okay PRO this is actually a right angle triangle okay so PR square should be equal to OP square plus OR square okay which is equal to A square plus X square okay ଏତିକି ବୁଝିପାରିଲ ତାପରେ ଏବେ ଆମେ calculation କୁ वापस ଆସିବା ଦେଖ up to this right so PR square ର value ହେଇଗଲା A square plus X square okay A square କୁ ଏବେ common ଆଣି ଆସିଲା okay ୟାକୁ ଟିକେ ସଜେଇ ଦେଲା now we apply the binomial theorem because x square by a square is very less than 1 okay so after applying the binomial theorem and calculating further we are getting the value of sr to be equal to here also তুমি লক্ষ্য করিব triangle SRO এটা भी right angle triangle ही हबो okay so SR रो value आमे पाउचु this much PR रो value तो एतिकी आसीगला okay now एतिकी जो SR रो value आसिला we again apply the binomial theorem okay again solve करिबा ताले final value SR रो आमे पाउचु केते this much okay now P dash R P dash R रो value हबो SR minus SP dash okay तो यार वैल्यू आमे एबे पुट करला जतकी पाइछु ओके सो p डैश r रो वैल्यू आमे पाइला केते दिस मच ओके एबे आमे पाथ डिफरेंस बाहर करि परिबा व्हिच इज pr minus p डैश r ओके सो देखो प्लस a minus a कटि गला कैलकुलेट करला फर्दर इट्स वैल्यू इज कमिंग आउट टू बी bx square by 2 into a whole into a plus b ओके ये हला पाथ डिफरेंस रो वैल्यूटा राइट एबे आमे देखिबा कंडीशन फॉर मैक्सिमा एंड मिनिमा फर्स्ट मैक्सिमा पाई Okay, so এই जो point of observation ଅଛି, okay, this will be a maxima କେତେବେଳେ ହେବ if the portion p dash of the wavefront is containing an odd number of half period elements. Okay, so the path difference should be an odd integral multiple of lambda by 2. Okay, now since each half period element correspond to a path difference of lambda by 2, so the condition for this maxima will be now given by jota ki ame path difference delta ro value paithila, this should be equal to odd integral multiple of lambda by 2 ଆଉ ଏଥିରୁ ଆମେ x ର value ପାଇଲା this much. Okay, ଏଠି जो n ଅଛି this is actually a number ଯାର value ହେଲା 0 1 2 3 and so on. Okay, ତାପରେ second ହେଲା condition for minima. Okay, for which the portion p dash should contain even number of half period elements so that the path difference should be equal to 2n into lambda by 2 or simply n lambda. ताहले condition for minima ହେଇଗଲା this much. Okay, so ଏଥିରୁ ଏବେ ଆମେ ଯଦି x ର value କାଢିବା, it's coming out to be this much, where again the value of n equal to 0 1 2 3 and so on. Okay, so ଏବେ जो आमे x ର value दुईटा पाइला, okay, गोटे maxima ପାଇଁ ଆଉ गोटे पाइला आमे minima ପାଇଁ. Okay, so ଏବେ एई दुई value को आमे compare ମଧ୍ୟ करि परिबा. Okay, so on comparing the above two conditions, we observe that the points of maximum intensity and minimum intensity lie at distance which is proportional to square root of 2n plus 1 and square root of 2n. Okay, এটি লক্ষ্য করো x ର value এটা minima ପାଇଁ. Okay, এটি দেখো ଆମେ লক্ষ্য କରୁଛୁ এଠି 2 ଅଛି, এଠି n ଅଛି. Okay, so square root of 2n ସାଙ୍ଗରେ এটা proportional. Similarly এଠି ଲକ୍ଷ୍ୟ କର maxima ପାଇଁ condition ଏଠି 2n plus 1 ଅଛି ଭିତରେ. Okay, ବାକି ସବୁ ଯଦି ଆମେ constant ନେଇଗଲା for a particular setup. Okay, a b याकू constant नेला ଆଉ for a particular light lambda को ମଧ୍ୟ ଆମେ constant ନେଇଗଲା, ତାହେଲେ କାହା ଉପରେ depend କରୁଛି n ଉପରେ. Okay, maxima ପାଇଁ କିନ୍ତୁ ଆସୁଛି square root of 2n plus 1, minima ପାଇଁ ଆସିଲା square root of 2n. Okay, ତାହେଲେ ଆମେ ଏବେ ଦେଖିବାକୁ ପାଇଲା ଯେ ଦୁଇଟା ଯାକ ସମାନ ଗ୍ୟାପ ରେ ନାହିଁ, maxima ଆଉ minima ଦୁଇଟା ଅଲଗା ଅଲଗା ଫ୍ୟାକ୍ଟର ଉପରେ ଡିପେଣ୍ଡ କରୁଛି. Hence the diffraction bands are having unequal width, right? So the distribution of intensity on the screen is shown now graphically in the figure. This one intensity को हमें y axis रे नीचु, distance from O को हमें x axis रे नीचु. Okay, देखो एपटे हला above O, एपटे हला below O, right? Now first discuss करिबा जदि below O. Okay, here you can see there is a very small amount of intensity, zero होनी किंतु सांगे सांगे. Okay, there is a sharp decrease in the intensity till it reduced to its minimum or zero value. Okay, above O जेतेबेले हमें देखिबा there is variation. Okay, एठी देखो there is variation here. The intensity एठी vary करूची between a certain maximum and minimum. Okay, so maxima गुडा एटा आसिला जो peak देखौची ऊपरे. Okay, positive peak गुडा और negative peak गुडा एटा होची तमरो minima. Okay, और gap टा देखो एठी कमी कमी जाउची as we are moving further or moving away from O. और कमी कमी की लास्ट रे यूनिफॉर्म डिस्ट्रीब्यूशन बा यूनिफॉर्म इल्यूमिनेशन ही जाउची, माने पूरा स्ट्रेट लाइन ही जाउची, राइट? सो एतिकी हला फिगर टा. सो दिस actually indicating the presence of diffraction bands. Okay, so intensity जो हमें देखुचु at a maximum it goes on decreasing and intensity at a minimum goes on increasing. माने ଯେତେବେଳେ ଆମେ ଗୋଟେ maximum ରେ consider କରିବା suppose this point, ତାହେଲେ या पर intensity କମୁଛି ଦେଖ. Okay, similarly ଗୋଟେ minimum ରେ consider କରିବା ତାହେଲେ intensity ତାପରେ ବଢୁଛି, right? And as we are moving to a larger distance from this point O, ताहले देखो এই gap टा कमी 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 पूरा zero हो जाउची. That means we are getting a uniform illumination. Okay, at a large distance from the point O. Okay, अच्छा. Now एबे देखो आमे जो मिनिमा और मैक्सिमा पाई x रो वैल्यू पाइथिला, सो आमे देखिला मिनिमा पाई it is proportional to square root of n, square root of 2n by square root of n, and maxima বা bright band ପାଇଁ it is proportional to square root of 2n plus 1. So ଏଥିରୁ ଆମେ fringe width ବାହାର କରିପାରିବା. Okay, so fringe width obviously it will go on decreasing as we move away from O because ଏଠି width ବା gap ଟା ସମାନ ରହୁ ନାହିଁ. Okay, so this will be again clear from the mathematical calculation. Suppose ଆମେ ଏଠି n ର value equal to 1 ନେଲା ତାହେଲେ x1 ଏବେ କେତେ ହେବ it is proportional to square root of n ମାନେ k into suppose square root of 1 that is equal to k ତାହେଲେ k ର value ଆସିଗଲା ଏତିକି. Okay, now n equal to 2 ନେଲା. Okay, so again we are getting k into square root of 2. Square root of 2 ର value ହେଲା 1.414. Okay, so width ହେଇଗଲା ଏବେ first bright fringe ର. Okay, first bright fringe ର ମାନେ ଏଠି width ହେଉଛି 0.414 into k. Okay, similarly width of second bright fringe ଏବେ second ପାଇଁ ଏବେ k into root 3 minus k into root 2. Okay, ତାହେଲେ ଦେଖ ଏବେ 0.318 k ଏବେ ଏଇ ଦୁଇଟା width କୁ ଏବେ compare କର ତାହେଲେ ଦେଖ କମି ଯାଉଛି as we are going to the higher order of bright fringe. Okay, now third bright fringe ପାଇଁ ଏବେ k into square root of 4 minus k into square root of 3 यार value आସୁଛି ଏବେ ଦେଖ 0.268 into k. Okay, so in this way this shows that the fringe width or the separation between the successive maxima will go on decreasing as we move away from the region of geometrical shadow. Okay, अच्छा suppose आमे ये जो light use करछु monochromatic न नेकी गोटे polychromatic light माने गोटे white light नेला. Okay, then कौन हबो अबे एठी will get few colored bands. Okay, colored by रंगीन band आमे पाइपा. Okay, and this will be observed in the region above the point O when it is illuminated, when the straight edge is illuminated with white light. Okay, now inner edge जो अछि the inner edge of the bands will be blue and the outer edge will be red in color. आमे जानिछु red color रो wavelength होछि maximum as compared to the blue color. Okay, so this is due to the fact that xn square is directly proportional to the wavelength. Okay, जो formula हमें पाइतला सेठी लक्ष्य करिवो xn square is directly proportional to wavelength. आउ जेमति कहली blue color ପାଇଁ wavelength टा कम रहिबो as compared to red color. So जो bands हमें पाउछु तारो जो band रो shorter wavelength रहिबो that will be narrower in size. Okay, finally एबे एई जो diffraction pattern आमे straight edge रे पकेई की यार वेवलेंथ जो लाइट रो आमे डिटरमाइन करि परिबा एटा प्रैक्टिकल भी करा हुए. ओके, सो गोटे स्ट्रेट एज नै जबा शार्प रेजर ब्लेड and it is set with its edge parallel to the slit and it is placed on one of the stands on an optical bench. Okay, now the slit is illuminated with a monochromatic source of light, generally sodium light use kara हुए. Okay, so that we will get obviously diffraction bands of unequal width. Okay, how यार intensity कमी कमी जिवो. Okay, when it is observed in the field of view of a micrometer eyepiece. Okay, now the position of first maximum intensity band and the one suppose nth one. Okay, first ଆଉ nth एई भितरे हमें कंपेयर करिबा maximum intensity ताले एबे हमें नोट करो फर्स्ट को हमें लिखिला suppose n equal to 0 ପାଇଁ x0 यार वैल्यू आसिला this one. Okay, तापरे for nth maximum intensity यार वैल्यू आसीगला this much. Okay, so xn minus x0. Okay, यार वैल्यू देखो एतिकी आसीगला. Okay, now distance जो अछि एठी small a होछि distance from the straight edge to the eyepiece याको हमें बाहर करि परिबा. Similarly small b होछि distance between the slit and the straight edge याको भी measure करि परिबा. Okay, so by knowing the value of xn and x0 जोटा कि तमे optical bench रो reading नेबो we can find the wavelength lambda of light. Okay, बाकी सब unknown quantity हम पाइगला. Okay, so एई experiment use करि कि हमें से monochromatic light रो wavelength मध्य measure करि परिबा. Okay, so this is all about the Fresnel diffraction at a straight edge. Okay,
Thank you.